Welcome to the MedEd podcast. I am Dr. Khan, and I am absolutely fired up today. We are diving into one of the most ingenious pieces of plumbing in the human body, the portal system. Think of it as the body's dedicated security checkpoint. Most blood in the body takes a straight shot back to the heart, but the blood coming from your digestive tract gets a forced detour. Why? Because you don't want raw, unfiltered material from your gut hitting the general circulation without a background check.
That is a very energetic way to start, Dr. Khan. To be academically precise for everyone listening, a portal system is defined as a unique vascular arrangement where blood passes through two capillary beds before returning to the heart. In the case of the hepatic portal system, the first capillary bed is in the gastrointestinal tract and spleen, and the second is within the liver itself. For your board exams, remember that this vein is formed behind the neck of the pancreas by the union of the superior mesenteric vein and the splenic vein.
Exactly. It is the ultimate pre-processing plant. Imagine the gut as a busy loading dock where all kinds of supplies, nutrients, but also toxins and bacteria are being loaded into the trucks. If those trucks went straight to the heart, it would be chaos. Instead, they have to go through the portal highway to the liver, which acts as the refinery. But Sarah, let's get into the nitty-gritty. Why does this matter clinically?
It matters because the portal system is essentially a low-pressure system, and significantly, the portal vein and its tributaries have no valves. This is a high-yield point for exams. Because there are no valves, blood flow can actually reverse if the pressure in the liver becomes too high. We call this portal hypertension. If the liver becomes scarred or fibrotic, like in cirrhosis, it acts like a massive traffic jam. The blood can't get through the liver sinusoids, so it starts backing up into the side streets or systemic circulation.
Right, and those side streets are the portosystemic anastomoses. Think of them like old, narrow back roads that were never meant to handle heavy highway traffic. When the main portal highway is blocked, the blood tries to find any way back to the heart it can. It forces its way into these tiny systemic veins. Imagine a garden hose that is designed for a little trickle suddenly being hit by a fire hydrant's worth of pressure. What happens? Those tiny veins start to bulge, and eventually they can pop.
That is a vivid analogy. On the boards, you must know the four primary sites of these anastomoses. First, the lower esophagus, where the left gastric vein meets the esophageal veins. When these bulge, they are called esophageal varices. Second, the umbilicus, where para-umbilical veins meet superior epigastric veins, creating that classic caput medusa appearance. Third, the rectum, involving the superior rectal and middle and inferior rectal veins, leading to internal hemorrhoids. And finally, the retroperitoneal veins.
And that esophageal one is the real killer. I was talking to our doctor of choice at the hospital yesterday about a patient who came in with massive hematemesis, vomiting bright red blood. This wasn't just a small tear, it was a variceal rupture. Because the pressure is so high and the liver is failing to produce clotting factors, these patients can bleed out in minutes. Why does this matter clinically? Because understanding the portal system tells you exactly where the danger zones are in a patient with liver disease.
And from a diagnostic standpoint, seeing caput medusa, those dilated veins radiating from the belly button, is a physical exam gift. It is a visible sign that the internal plumbing is under extreme stress. Students pay attention to the venous drainage. The superior mesenteric vein drains the midgut, while the splenic vein handles the foregut and receives the inferior mesenteric vein from the hindgut. If you know these territories, you can trace exactly where the congestion is starting.
It's all about the pressure gradients. If the liver is hard as a rock from cirrhosis, that pressure is going to travel backwards through the entire system. It's like a backup in the city's main sewer line. Eventually, things are going to start overflowing in places you really don't want them to. We even see this with the spleen. The blood backs up into the splenic vein, the spleen gets engorged, and suddenly your patient has splenomegaly. Why does this matter clinically? Because a big spleen is a vulnerable spleen, and it can actually start trapping and destroying blood cells prematurely.
That leads to thrombocytopenia, which just makes the bleeding risk from those esophageal varices even worse. It is a vicious cycle. Another board-relevant detail is the nature of the liver capillaries, or sinusoids. The book mentions they are wider and more irregular than standard capillaries. This allows the liver cells, the hepatocytes, to have maximum contact with the nutrient-rich portal blood. It's a design built for efficiency, but it's also the first thing that gets compromised when the liver's architecture is destroyed.
So true. I always tell my students, the portal system is the body's quality control department. It ensures the heart only gets the good stuff. But when the department is closed for business due to disease, the whole body pays the price through these dangerous detours. If you can visualize those 4 back roads Sarah mentioned, you can predict almost every complication of liver failure.
To wrap this up for the students, focus on the fact that the portal system has 2 capillary beds and no valves. Know the union of the SMV and splenic vein as the origin of the portal vein. And most importantly, memorize the sites of portosystemic anastomoses, esophagus, umbilicus, and rectum, as these are the high-yield clinical manifestations of portal hypertension.
Brilliant summary, Sarah. The big takeaway is that the portal system is a detour with a purpose. Understand the detour, and you'll understand the disease. Thanks for joining us today, and keep those clinical gears turning.